Hey everyone, in this video, we're building a beautiful, modern expense tracker app using Python and Flet. Add your daily expenses in seconds. Just punch in the title, amount, category, and date. Want to check your monthly spending? Simply filter by month and instantly see where your money went. Get beautiful visual insights, from PieCharts to category-based progress bars, all updating in real time. Every expense is neatly displayed in a clean card-style layout. Made a mistake? Just click delete. Done! And the best part? All your data is saved automatically. No databases, no login. Just run and track. Simple, smart, powerful. This is the expense tracker you'll actually enjoy using. Now, if you want to create this expense tracker, stick with me till the end. I'll walk through each line of code and break it down in both a technical and simple way. Let's get started. Make sure you have installed Python and then Flet. Check the link in description for the installation steps. It's very simple. First things first, importing the libraries. Flet, that's the UI framework we're using to build the app. Datetime helps us work with dates. JSON, for saving and loading our data in a file. OS, for checking if our created or saved file exists. And default dict makes it easy to group expenses by category automatically. Well, see that below. Hey, if you're new to the channel, please like, comment, and subscribe. It will help my small channel to grow quickly, since you know it's very difficult for small creators like me to grow in the midst of high competition, and it will motivate me to create more interesting projects for you. Thank you. Let's continue. After the import and setup, we will now declare and initialize global variables. Global variables are those variables which can be used and edited anywhere inside the code file. Inside a function, outside a function, like anywhere. That's the simplest explanation. So, the global variables that we have declared and initialized are expenses. It's a list that will store all our expense entries. Selected month. This will track the selected month for filtering. Months. This is the list of all the months from January to December. We will include all. You'll come to know why. Data file. This is the file name where we store our expenses. Now, we go to the main function. Here, we define our main function that runs your whole Flet app. Think of it like the starting point or the heart of your application. It tells Flet, when the app starts, run this function and give me a page to work with. We're passing a page object to the function and telling the function that this page is expected to be a page object from the Flet module. This page object is like a blank canvas where you add your UI elements, like buttons, text fields, charts, etc. Inside the function, we are starting with the page setup and styling. We are setting the app title, dark theme, padding, and a scrolling for the app. Now, to persist the data even after the app is closed, we need to save the expense in a file. The name of the file we have already put in the global variable above. Before creating any elements on the page, we will first load the expenses that we have saved, or will save in that JSON file. For that, the load expenses function is created, and we call that function here. Let's see how and what we do inside that function. We first check if the file expenses.json exists in the folder where your code is. This prevents errors when the app runs for the first time and the file doesn't exist yet. If the file exists, we open it in read mode, where R represents read. The with statement ensures the file is properly closed after reading, so we don't have to close it. We use json.load function to convert the file's contents, that is JSON text, into a Python list of dictionaries. Now, we loop through each saved expense in the loaded list. For each saved expense, we extract title, amount, and category as is. We convert the saved date string, like 2024-09-21, back into a real date object using datetime.strptime.date method. Then, we append this full expense dictionary to the expenses list that we initialized in the beginning. Now we create the required elements that we need to show on the page, starting with a title for the app. Using the title class of Flet module, we create a title. We will give the font size, make it bold, and give it a color. You can watch my video on the basics of Flet to understand all these basic fields like text field, button, dropdown, etc. Next, we will display a dropdown. This will be our filter, to filter the expenses according to the month. Dropdown UI component is created using Flet class name dropdown. This sets the label, text above the dropdown, to filter by month, so users know what it's for. We're building the list of drop-down options using a list comprehension. Months is a list of all months that we have created above. For each month, we create an option in the drop-down, using the option class of drop-down module. This populates the drop-down with those 13 choices. This sets the default selected option to all, meaning by default the app will show all expenses. Now this line does something very important. It tells the app, hey, whenever the user selects a different month from the drop-down, run these two functions, refresh UI and update PieChart. Let's go step by step. OnChange is an event handler. Think of it like saying, when the user changes something in this drop-down, do this. In our case, we want the app to react whenever the month is changed, just like apps do when you select a filter. Lambda is a shortcut way to define a function without giving it a name. E stands for the event, which we don't actually use here, but it's required. And passing these two functions, refresh UI and update PieChart, means run these two functions. So it simply means when something changes in the dropdown, do these two actions. Why do we do this? Because we want the app to feel interactive. If you choose January, the app should only show January's data, and the chart should change instantly to match. We'll see the two functions further in the code. After creating the dropdown, we create the input fields for adding a new expense. We create the amount field, where you will enter the amount. Then, the title of the expense, where you can enter what, why, or where you have spent. It depends upon you what to put there. Then we create the category of the expense to enter the kind or type of expense. This line creates a date picker control in your Flet app, which lets the user select a date from a calendar-style pop-up. Date picker. This is a component from Flet that gives users a clickable calendar UI to choose a date. The first date sets the earliest date the user can pick. Here we kept it as January 1st, 2023. For latest date, here we have set the latest date to today's date, so users can't select a future date, which makes sense for an expense tracker. You only log past or current expenses. Page.overlay is like a special layer on top of the normal UI. It's used for components that pop up or float above the page, like dialogues, date pickers, or menus. Append. This tells Flet to include the date picker in that floating overlay layer. Why it's important? Because when you call something like datePicker.pickDate method later in your code, Flet will look in the page overlay for the date picker and show it as a pop-up. If you forget to append it to page overlay, even if you call pickDate method, nothing will happen. The date picker won't appear. This creates an empty pie chart in your app, which will later be filled with data like expenses by category. Sections. It's for the slices of the pie. Here it's blank, starts with no slices in the pie chart. We'll add them dynamically later. Sections. Space 2 adds a small gap, 2 pixels, between each slice, so they don't touch directly. Center, space, radius, P40. Leaves a circular hole in the center, like a donut. Just for style, expand true makes the pie chart fill all available space in its container. The elevated button class is used to create a button that the user will click to add a new expense. We give it a text to be shown on the button. OnClick connects the button to a function called addExpense. When the button is clicked, that function runs. And the style here gives the button rounded corners with a radius of 12. It makes the button look more modern and friendly, like a soft, pill-shaped button. Now here we are putting all the elements that we created above in a row: title, amount, category, date, add button. It's for arranging all the elements nicely in a row that adjusts responsively. That is, it looks good on different screen sizes. We created a button for selecting the date. On clicking the button, the date picker class with pickDate method is called using lambda function. Everything is arranged in one clean row. Then below, after all the elements, we write the total amount spent, using the text class. To understand rows and columns, you can check my video on the basics of Flet Python. Then just declared some columns that will be filled dynamically, that is expense list and category bars. See, we have just created the elements, but we haven't yet displayed on the page. So, to display on the page, we need to add all the elements to the page by using page.add method. We'll put all the elements inside the column and add to the page. Now here, we have put our pie chart inside a container. The container class creates a container box that holds a pie chart. The content-pie chart means to show the pie chart inside this container. Why use a container? It gives a fixed size and spacing to the pie chart, so it doesn't stretch or shrink oddly on different screen sizes. Then, the divider class. This adds a horizontal line underneath the pie chart. It's just a visual break to separate different sections of the app, like between the chart and the expense list. For now, I'll comment some parts of the code and execute all that we have seen till now. Let's execute and see how our app looks. Oh, that looks nice. You can see the title and how beautifully the elements are placed in one below the other. Then, here's the date picker. And on clicking it, a calendar pops up. You can see the first date is of 2023 and latest at today's date, which is exactly like we wanted. Then the below empty space is where our pie chart, progress bar, and expenses will be displayed. Right now, we have just initialized and there is no data, so it's blank. So, let's go back to the code and see the functions. Let's first see the add expense function, which gets triggered when the user clicks the add button. So here the first thing what we do is very basic. It must be done every time we have any user inputs, and that is a validation check. So this line checks whether all the input fields are filled by the user. If any field is empty, amount, title, category, or date, it simply returns and does nothing. This prevents adding incomplete expenses. Then, we create a dictionary with the user's input: title, amount, category, date. Dictionary in Python is similar to JSON format, that is, key value pairs. And since we will be storing the data in a JSON format, we create this dictionary for each expense. Then, this dictionary is added to the expenses list that we created. So every time a new expense is entered by the user, this dictionary is created and added to the expense list. Then we call the save expenses function. Let's see this function. This function will save all expense data to a file on your computer, so it's not lost when you close the app. So, first we open the file for writing. Data file is the name of the file where expenses will be saved. We already initialized it at the beginning. The W means write mode. It will overwrite any existing data in the file. F is the variable representing the open file. With makes sure that the file is automatically closed after using or writing in it. Then, using list comprehension, we creating a list of dictionaries. Each dictionary will have data of each expense. You might think, we already did that in add expense function. Yeah, true. But if you see here, we are converting the date into a JSON serializable format. Actually, the date we stored is in the form of a Python object and will not work if we directly try to store it in JSON file, because that object is not JSON serializable. Hence, we are creating a list here again. So, the list comprehension is doing the following. For each expense E in the expenses list, extracting the title, extracting the amount, extracting the category. formatting the date from a Python datetime date object into a string, like 2023-09-21, using strf time function. So it turns the list of expenses into something JSON-friendly. Then, JSON.dump function writes the formatted list into the file f as JSON format, which is a common format to store data that looks like Python dictionaries and lists. JSON makes it easy to reload the data later, like when the app starts again. Going back to the add expenses function, after saving the expenses in a JSON file, we clear all the input fields. So this line resets the input boxes back to empty, so the user can enter a new expense easily. After creating and saving the expenses in the JSON file, we call the refresh UI function. Now this is the most important part of the app. This function filters expenses based on selected month, updates the progress bar summary for each category, updates the expense cards, updates the total amount, finally, refreshes the page view. So this first line here gets the selected month from the dropdown and stores in the month variable. Filtered variable will store expenses that match the selected month. Total will have the total of expense amounts. Chart data. We are creating here a special dictionary using default dict class of the collection module. So chart data becomes a default dictionary. What it does is, whenever you look for a key that doesn't exist in the dictionary, it will throw a default value rather than a key error. Here, the default value type we have given is float. So the default value will be 0.0. Then we have a for loop that will loop through each expense from the expenses list. First, it extracts the month name from the expenses date. Then it checks if the expense month is equal to the month selected in the dropdown, or if all is selected from the dropdown. If it does match, then adds the expense to the filtered list which we created to store all expenses that match the selected month. Then it adds the amount of each expense of that month to the total amount variable, and then creates an expense category key inside the chart data dictionary and adds the amount of that expense. By this, we will have a dictionary of all categories with their respective total amounts for the selected month, and in case of all, it will be for all months. After that, we move ahead to create the progress bar to visualize the spending according to the categories. This line just clears any existing category bars before adding new ones. Category bars is the column that we created earlier, where we will display the spendings. Then, we have another for loop. This loops through each category, cat, and its total amount, in the chart data dictionary. Inside the loop, we first calculate the percentage to display the spending percent for each category. Then we create a column consisting of a text that will show on which category how much was spent, and the progress bar for a nice visual, and then append it to the main column that we created. That is, the category bar. So, at the end of the for loop, the category bar's column object will have all the expenses according to their category and a progress bar for each. Now, in the same way like the category bar's column, we have expense list column, where we will display the expenses in a card form. So again here, first we have cleared any existing expense cards before adding new ones. Then to display title, amount, category, and date, we put them inside a column. Then we create a delete button using the icon button module, and since we want the text and the button on the same line, we have put them all in a row. Put all of this in a container, then we have done some styling to the card, like elevation. It will give a nice shadow to the card, and it will look like elevated or poked up. Then color and shape. And put all of this in the container class holds all the column and rows together. And finally put it inside the card class, and then we add the card to the expense list column. Next, we update the label that shows total expenses for the selected month. This is the text variable we create earlier. Page.update function forces the app UI to refresh and show all the changes made above. Now, let us see what happens when delete button is clicked. Here we are calling the delete expenses function. Let's see how we called. Lambda, a way to create a small, unnamed function on the fly. E. This is the event that gets passed automatically when the button is clicked. You don't have to use it, but it must be included. IDX. We assign the current expense index or position, IDX, to I, so it doesn't change unexpectedly. Delete expense. This calls the function to delete the expense at the correct index. Why this is needed? If we just used lambda, delete expense, IDX, Python would wait until all the loops finish, and IDX would end up being the last index every time. So all buttons would delete the last item. By using I equals IDX, we capture the correct value of IDX at that moment. Now, inside the delete expense function, we first do expenses.pop index, removes the item at position index from the expenses list. Save expenses, updates the JSON file on disk, so the deleted item is also removed from storage. This function, refresh UI, rebuilds the UI to reflect that the item is gone, that is, it removes the card visually. We saw this function too. Update PieChart recalculates and redraws the pie chart to show the new distribution after the deletion. So now our next function is update PieChart. Inside this function, at first we store the selected month value from the drop-down into the month variable. Then we create a default dictionary same like we created earlier, so I won't go more in details. Then we create a for loop to go through each expense in the list. First, we convert the expense date into the month name. If the user picked all months, we include all expenses. Otherwise, only include expenses that match the selected month. This part adds up amounts for each category. This is similar to what we did earlier for chart data. Now, once we have the dictionary ready, we create the sections for the pie chart. Remember when we created the pie chart, we kept the sections blank list. Now here we will create it. Each pie chart section needs value, the size of the section, how big it is, title, the label shown on the pie color, alternates between cyan and teal for better visibility, I%2 equals to 0 means, use cyan for even sections, teal for odd ones. And finally, PieChart update function. This tells Flet, I've changed the data. Now redraw the pie chart on screen. This is the entry point to run your Flet application. It's telling Flet, hey Flet, start the app and run the main function. Now, I know you're waiting to see the app. Let's execute our code. Wow, that looks beautiful. So let's fill in some expenses, enter the title, amount, category, and pick the date. Then click on Add, and here you go. You can see a pie chart. Then below that is the progress bar where it shows the percentage. And there's the expense card. I'll fill up some more expenses. Now you see all the expenses. You can delete them by clicking on the delete icon. Now, let's close the app and open again to check if the expenses are still shown on the page. And yes, the expenses are still visible. So coders, that was a beautiful expense tracker app with modern UI. Create now of your own and comment below. See you next time.